A very good morning, dear students. Welcome back to this session. In this session, I am going to discuss on chapter 4, that is software concepts. So let me begin this class with the agenda. The agenda goes like this. The recap of what are the concepts which I discussed in the earlier classes. So that is, what do you mean by what do you mean by hardware? The hardware means the physical components of a computer which we can able to touch and feel is called as hardware. And what do you mean by software? Software means it is a set of collection of programs related of some similar data to perform some specific task or some common task. So in softwares there are of two types. So one is system softwares, another one is application softwares. Is it right? So system softwares, in the sense these are the collection of programs. So it is written to perform some common task. So for example, Windows. So all the system softwares are written in low level languages. So in this system softwares we are having three types. So one is operating system, language translators and utilities. So in that three system softwares I discussed about operating system. So what is operating system? So operating system is a system software which acts as an interface between computer and the user. Is it right? So examples may be command based operating system or graphical based operating systems. So that is the command based operating system is DOS and graphical based operating system is Windows. So user friendly is GUI operating systems. So and then I discussed about some of the functions of operating systems. So what is the functions of operating systems? So operating system manages the memory, it manages the processes, it manages the devices which is connected to the system, and which manages the files which is located in any drives, and which gives protection and security for the system. And the user interface can be either command based or it can be either graphical based. So these are the functions of operating systems. Functions in so and then I also discussed about some types of operating systems. So there are many types of operating systems, around 6 plus 4, that is around 10 types of operating systems. So in that I discussed only two, that is single user operating system and batch processing operating system. So single user operating system, in the sense only one user will be there in front of the computer and he will be working. So this kind of operating system is seen in usual laptops or computers. So then batch processing operating system, in the sense in that there are similar programs are collected and it is made as a group, and then one after the other the instructions are executed batch wise. So that is batch processing operating systems. So I gave an example, that is IBM 360 computers. So for single user operating system, so that is MS DOS. So okay, these are the concepts which I discussed in the earlier classes. So let me discuss today's class concepts. So in today's class I am going to discuss with the concept type of operating system. So that is multi-programming operating system. So in multi-programming operating systems there are four kinds of operating systems. So one is multitasking, another one is multi-user operating system, another one is time sharing operating system, another one is real-time operating system. So these operating systems comes under multi-programming operating systems. Okay. So let me discuss what is this multitasking operating system. See, this is a diagram of multitasking operating system. See, you are having some document. So some document you are readying, you are making it to ready, and then you are composing some mail, or else you are checking some mails. Okay, and you are surfing in the web browsers. So all these things has to be managed so by the operating system. So here how many tasks are done? So this is a task 1, so this is a task 2, this is a task 3. So all these 3 tasks are assigned by the operating system to the processor. Okay, so this is how multitasking happens in the computer systems. So understood? So here more than one task is attained at a time by the operating system. So it will schedule by scheduling algorithms. So T1, T2, T3. So all these things will be assigned by the operating system for the CPU. One which task has to be executed first, and then which task has to be executed next. There is a few milliseconds gap between the task which is going to be executed. So this is the multitasking operating system diagram. I hope you all are understanding. So let me discuss the theory part of it. So multitasking operating systems allows more than one program to run at a time. So as I told, there are many programs. So there are many programs which is running at a time, so that the operating system assigns at a time all these three programs. Okay, it gives you the perception of two or more tasks running at a time. It does this by dividing system resources among the task. So as I told, you can assume all these three tasks it will do by dividing the system resources. So what is meant by system resources? Memory. So memory is a main system resources. In CPU, this memory is captured and divided. Okay. So like this, the multitasking operating system will do. And it is usually implemented by code and data of several programs in memory simultaneously, and multiplexing processors and input-output device among them. So what are the resources which are used here? So which are used here is memory. So memory is used simultaneously, and also it uses multiplexing processors. So processor in the sense it is going to process the data. So i3, i4 in the sense Intel core processors. So all these processors are used to assign the task. And then it is also called as multitasking, is also called as context switching. So multitasking is called as context switching. So multitasking usually refers to a single user. So single user performing many tasks. See here, single user is sitting here and he is doing some many tasks with respect to one particular system. So example is as usual Windows versions. So Windows 98 is one example for this multitasking. So multitasking in the sense more than one task is assigned or it is running at a time. Okay, so here the memory is divided. So divided among the system resources, and then it uses it is also called as user in the sense many users. Multi means many, users means the user who is going to use the computer. So here you can see in this picture there are user 1. So see, here the user 1 is sitting and doing with the working with the computer, user 2 is sitting and working with the computer, and user 3 is sitting and working with the computer, user 4 is sitting and working with the computer, and user 5 is also doing the same thing. So here there are multi users. So multi users means more than one users are working at a time. Okay students, so let me move on to the theory part of it. So multi-user operating systems allows the multi-users on different computers or terminals to access a single system with one OS on it. So see here, you are having only one OS and one system, is it right? So it allows one user to sit along with the system and to do able to work. Okay, and here it creates and maintains individual environments. So here it is creating individual environment and individual authentication and security level, provides per user resources usage accounting, in the sense it creates and maintains individual accounts. For example, in your system you will be having one system will be having many different usernames, is it right? So for every username there will be a different username and password. Individual user have individual access for the each operating system. Okay. So next we'll move on to the time sharing operating system. So time sharing operating system, in the sense here you are having many users and here the users are using the same CPU time. See here the CPU time is used is the same. So user 1 is accessing the same CPU resources which is available, user 2 is accessing the same resources which is available, user 3 is also accessing the same resources which is available, same as it is for all the other 3 resources. So what does it means? Means it operating system, time sharing operating systems allows the many users to share the computer resources simultaneously. See what is the computer resources here? So computer resources is what here? Memory. Is it right? So here computer resources is this CPU. Okay, so this CPU is allocated from all the users simultaneously. So this means time sharing operating system. And then time sharing refers to the allocation of the computer resources in time slots to several programs simultaneously. So that is here the user 1 can use the time T1, user 2 can use the time T2, user 3 can use the time T3. So like this the users can share the times between for the same processing systems belong to this time sharing operating systems. So large content of CAD systems and text processing systems will also belongs to this time sharing operating systems. So next is most of the time sharing operating systems adopted time slicing or round robin scheduling algorithms. So there are many kinds of scheduling algorithms. So round robin scheduling algorithm is applied for this time sharing operating system. Okay, and then each user or process will receive a portion of the time slot. See here user 1 has the access to the CPU at one point of time. Same as user 2 will also have the access to the CPU at some point of time. So like this all the users will have the access to the CPU at some point of time. So next is the Unix or the Windows servers is the example for this. Okay, multi-programming, multi-use and time sharing systems. So here, so in the last this one multi-user operating system, so time sharing operating system. See here in multi-user operating system, each system will have the different accessing of password and username. Is it right? But here in time sharing systems it is used in Unix and Windows servers. Okay, and also in multi-programming and multi-use and there and all it is used. Okay, so next is real time here and the user applications is here and custom hardware is here. So this operating system acts as an interface between the applications and the computer hardware. So let us discuss what is this. So real-time operating system refers to a computer and software systems so that responds to the events before the events become absolute. So before the event is going to be happen, the real-time systems is going to respond. The primary objective of real-time systems is to provide quick event response. So what is the objective of real-time systems? So it is used to provide quick event access. So quick event response, and thus it schedules the algorithms, and thus it schedules the deadlines. Okay, so this means the real-time operating systems. So and its applications are used in military applications, Linux operating systems, and Windows CE, and flight control. So they run all the industry control systems, medical imagining systems. So all these applications includes the real-time operating systems techniques. Okay, so next is distributed operating system. So this is a fourth kind of operating system. So in the multi-programming operating systems, see here, so multi-programming operating systems includes all these four things. Okay, multitasking, multi-user, and time sharing, and distributed operating system. So distributed operating system, in the sense only one operating system is divided among the three or more machines. So machines in the sense the hardware, the computer is called as machine. So here for the same mission A, the same operating system is used. For mission B, the same operating system is used, and for the mission C, the same operating system is used. Okay, so what does it mean? A distributed operating system is a collection of autonomous computer systems capable of communication and cooperation via the software and hardware interconnections. So here that is distributed operating system will have only one operating system, and it is working between all these three hardware computers. So between all these three things there is a cooperation, so that it can able to work with all the softwares which has to be installed, and with all the hardwares which has to be installed. Okay, so next is for example, if we have n systems in the distributed environment, then distributed OS helps in balancing the load by sharing the processors, input output devices, and memories, etc. So if there is a n operating systems like this, one after the other, the systems like this, and OS is used only one. So OS has to be distributed for all the systems, in the sense at that time how it manages, in the sense by loading the sharing processors. So processors is shared, and then input output devices is also shared, and memory is also shared. So all these three things are shared, so that the ATM centers of a bank are examples for this distributed operating systems. So how? So different ATM banks will have the different access numbers, is it right? So how it is accessed? So with the help of the same, by loading the shared processors, input output device, and memories. So next is networking operating system. So here you can see in this picture, so this is a networking operating systems. So see here you are having different terminals. So terminals in the sense node. Okay, see this is having the PC, this is having another one PC, and here you are having one projector thing, and here you are having one computer. So this is how network operating system will look like, and here there is a collection of softwares that is associated with the protocols that allows which is connected with the help of internet connections. So it provides a convenient and cost effective manner. See here in cyber cafe and all, you will be having different systems, is it right? And from the in the owner counter there will be one printer and one system. So if you are giving print from this system, you can able to take out the printer from this system which is there near the bill counter. So this is how the networking can be done. See here the products, so the hardware devices used is minimized. See, we cannot able to purchase all the printers for all these individual systems, is it right? So with the help of this networking we can able to print, so print from any one of the computer. Okay, so this is the same implication here. See here you can able to connect with all the other systems. So these all the systems which are connected to this system. Okay, so in a network operating system, the users are aware of the existence of multiple computers and can log into the remote machines and copy the files from the one machine to another machine. See here in network operating system NOS, you can able to actually copy the what are the files which is there in that network to another system. Okay, so from one A system to from another one B system you can able to copy if it is NOS, if it is connected to NOS. So example, main example is Windows NT. Okay, Windows. Okay, so next is multi-threaded operating systems. So this is a multi-threading operating system. So thread in the sense it is a process. So okay, see here you are having only single thread, means you are doing only one task at a time, but here you are having 3 threads. See here the code, the registers, the stacks are divided into 3 segments. Okay, see here you are having 3 threads, so only it is called as multi-threaded. So thread is a sequence of instructions within a program. So thread is a lightweight process. A program or process may have many threads which share the same code section, data section and other OS resources. Okay, it also provides many logical paths through the program to be executed simultaneously. See here you are having, see same the code registers and stacks are shared for one threads. The same other it is divided into 3 segments when it comes to 3 threads. Okay, so this is how the multi-threaded programming will be executed simultaneously. So thread in the sense sequence of instructions. So one instruction for example to write one, so to print some paper. So here I'll give, so this is a thread 1. So here I'll give print 100 pages. Here I'll give print, and again another instruction I'll give 1000 prints, and here again I'll give 2000 prints. So here in this becomes multi-threaded. Okay, so examples are sun. And also it may include multi-threaded Unix and multi-threaded Linux. Okay, so this is about today's concepts. If you are having any questions, do ask the questions. Okay, so what are the questions which may arise from this chapter? I'll be discussing now for a minute. See, the questions from this chapter can be, what is a program? So program in the sense set of instructions, so it is written to do some particular task. So next is, what is a hardware? So hardware in the sense the physical components of a computer which we can able to touch and feel. What is a software? It is a software means it is a collection of programs which we can able to do certain task or common task. Okay, give an example for high level language. So what does it mean? High level language in the sense any application programs you can give. Okay, And then what is a system software? Okay, what is the application of software? Okay, what do you mean by operating system? So this is a one of the important question. What do you mean by operating system? So it acts as an interface between computer and the users. So these are some of the 1 mark questions. And then what is GUI? Graphical user interface. What is multitasking? So do compiler or computer performing one or more tasks at a time. And then what is a linker, what is a loader. So these things I'll be discussing in the next classes. Okay students, so I hope you all are understanding. If you are not able to understand the concepts, do join the Zoom meeting. Okay, thank you all.